Very good morning, class. This lecture is about cloud-based application development and management, and the code is TCS 552. Myself, Dr. Sachin Sharma. We are discussing Unit 5, the cloud application. Why is cloud essential to the success of IoT? It's like just cloud computing, which is built on the tenets of the speed and scale. IoT applications are also built on the principle of mobility and widespread networking. Hence, it is essentially both cloud and IoT form cloud-based IoT application in a bid to make the most out of their combination, and that alliance has led to the success of IoT. As you know that IoT has limitation, and the cloud computing fills that limitation and make IoT advance. In addition to that, here are few more pointers as to why the cloud is important from the point of view of IoT success. The first one is it provides remote processing power. Cloud as a technology empowers IoT to move beyond regular appliances such as AC, refrigerator, etc., and that is because the cloud has such a vast storage that it takes away dependencies on on-premises infrastructure. And with the rise of miniaturization and transition of 4G to a higher internet speed, the cloud will allow developers to offload fast computing process. The second one is it provides security and privacy. The IoT's role in harnessing mobility is immense. However, its powers would be incomplete without security. The cloud has made IoT more secure with preventive, detective, and corrective controls. It has enabled users with strong security measures by providing effective authentication and encryption protocols. In addition to that, managing and securing the identity of users has been possible for IoT products with the help of biometrics, and all of this is possible because of the cloud security. And the third point is it removes entry barrier for hosting providers. Today, many innovations in the field of IoT are looking at plug and play hosting services, which is why the cloud is a perfect fit for IoT. Hosting providers do not have to depend on massive equipment or even any kind of hardware that will not support agility IoT devices require. With the cloud, most hosting providers can allow their clients a ready-to-roll model, removing entry barriers for them. The fourth point is it facilitates inter-device communication. The cloud acts as a bridge in the form of a mediator or communication facilitator. When it comes to IoT, many powerful APIs such as Cloudflare, Cloud Cache, Dropster are enabled by cloud communication, which allow easy linking to the smartphones, and which is very important for IoT. This eases device to talk to each other and not just us, which essentially is the tenet of IoT cloud. And also it would be very fair to say that cloud can accelerate the growth of IoT. However, deploying cloud technology also has certain challenges and shortcomings. Not because the cloud has flaw, but the combination of IoT cloud can burden users with some obstacles. If you ever go ahead with an IoT cloud solution, it is better if you understand the challenges that you may face in advance. Let's talk about the challenges which are posed by cloud and IoT together. Handling a large amount of data. It is one of the big challenge. Handling a large amount of data can be overwhelming, especially when there are millions of devices in the picture, as we saw in the view graph in previous lecture, and this is because the overall performance of the application is at stake. Following the NoSQL movement could be beneficial, but it is not tried and tested for the long run, and which is why there exists no sound or foolproof method for the cloud to manage big data so far. Networking and communication protocols. The cloud and IoT involve machine to machine communication among many different types of devices having various protocols. Managing this kind of a variation could be a tough since a majority of the application areas do not involve mobility. As of now, Wi-Fi and Bluetooth are used as a stop gap solution to facilitate mobility to a certain extent. So if you have Wi-Fi connection, Bluetooth connection, still you move, the device will be connected to each other at certain range. Next is sensor network. These sensor networks have amplified the benefit of IoT, and these networks have allowed users to measure, infer and understand delicate indicators from the environment. However, timely processing of a large amount of this sensor data has been a major challenge. Though cloud provides a new opportunity in aggregating sensor data, it also hinders the progress because of security and privacy issues. In this view graph, we will discuss about the four-stage IoT solutions architecture. Stage number 1, sensors and actuators, which can be wired or wireless. Stage number 2, internet gateways or data acquisition system, where data aggregation, analog to digital measurement and the control can be done. Stage number 3, edge information technology, which has analytics and pre-processing. Stage number 4, data center and cloud, which has analytic management and achieves. In all four stages, security, end-to-end, proactive, defense in depth, ecosystem, open, extensive and partner-driven, services, advise, transform, integrate, operate and manage. When we talk about the stacks, data flow and control flow, which has analytics, management, control, and it's vice versa from stage 1 to stage 4. And we talk about the things, the primarily analog data resources, devices, machines, people, tools, cars, animals, clothes, toys, environments, buildings, etc., which are connected to all together in all the four stages, and the visualization is there. And when we talk about the edge of the ecosystem, then after stage 2 there is edge between stage 2 and stage 3. So this is the view graph, 4-stage IoT solution architecture. That's it for the day. I hope you have enjoyed the lecture. Thank you.